class. So this is a new chapter of science, and this is the last one as well. So I'm going to send you this link as well for the simulation. So you'll make different electric circuits and see the working of that. Now 10.1, so this is chapter number 10 of your textbook. So 10.1 basically aims to introduce you the electrical circuits. So this is a simple electric circuit, right? So in a simple electric circuit, you have a battery which provides the energy that allows the electric current to pass through a wire and then goes to the electric component where this electrical energy is converted into other forms of energy. In this case, it converted into light energy, and then come back to the negative terminal of a battery. So remember, electric current always passes from the positive terminal of a battery to a negative terminal of a battery. And also a positive electric current cannot pass through this positive terminal to this negative terminal within this battery. So it needs to take an outer route that is through the wires. Now this is a simple electric circuit. You have a battery that provides energy. You have a switch that closes or opens the circuit. You have an electrical component that uses this electrical energy in other forms of energy, and you have a wire which conducts electricity. Now, in the introduction, you're going to be introduced to some of the important terms such as electrical conductor. So electrical conductor is anything or any substance that allows the flow of charges through itself. So electrical current is basically the flow of charges, right? The rate of flow of charges. So anything that allows the rate of flow of charges through itself is called an electrical conductor. So a substance that allows the electric current to pass through. Now, if you think of a wood is not a good conductor of electricity, but if you think of a metal wire such as copper, you know that copper is a very good conductor of electricity, right? Even water is a very good conductor of electricity. That is why we are advised not to touch the bell when it is raining. Now, electrical energy. Electrical energy basically provides the energy that drives the flow of electrical charges through an electrical conductor. So it basically provides a push force to the electrical charges to flow. Okay? And then electric current. So electric current is produced when electric charges move through an electrical conductor. So the flow of electric charges is called an electric current. Electric circuit is the path along which electric charges move. So when electric charges are moving through this path, we call this path an electric circuit. And this thing is basically providing the energy that drives the electric current or the flow of charges through this circuit. Now let's talk about an open circuit and a closed circuit. So the rule of thumb is that when there is a discontinuous path, you're going to say it's an open circuit. When there's going to be a continuous path, you're going to say it is a closed circuit. So you see that when current moves from the positive terminal to the negative terminal, when it is moving, it then realizes that there's a gap. And whenever there's a gap, the current cannot go further, right? So this bulb is not going to light up. But when there's a continuous path, then current will start moving from the positive terminal to the negative terminal. And as there's a closed path, so that means this current will be able to reach this electric component where the light energy will be converted into, where the electrical energy will be converted into this light energy. Now, representing simple circuits using symbols. Now, when you're drawing a diagram, especially, you cannot, it is, number one, it is very time consuming, and number two, it consumes a lot of energy to make such diagrams. So we have certain schematic diagrams where we use symbols in place of these real images, right? So in place of a switch, we will use this symbol. In place of an electric cell, we use this symbol. So this longer vertical line basically shows a positive terminal, and this shorter vertical line basically shows a negative terminal. For voltmeter, you have V encircled which is encircled, and then you have for ammeter you have A, which is encircled, and for galvanometer you have G, which is encircled. For a bulb, you use this symbol. Then likewise for battery, because battery in science basically means when there are two or more cells connected in series, right? So for one cell, you're going to have one positive terminal and one negative terminal. So when you have three cells connected in series, so you're going to make this symbol, right? Why am I saying 3? Because you have 3 positive terminal and 3 negative terminal. For millivoltmeter, you're going to use MV and encircle that. You're going for milliammeter, you're going to write MA in a circle. For microammeter, you're going to use micro and ammeter. So these are different measurements, milli, micro, milli and micro. So you learned that in maths. Okay, now for wire, you're going to use for joint wires. That means one wire is connected to another wire. You use this symbol. When you have one wire crossing the other wire, you use this symbol. When you have a fuse, you use this symbol. For power supply, you use this symbol. For bell, you use this symbol. For magnetizing coil, you use this symbol. So in this, you don't need to know what is the role of each of them. What you need to know is that there are symbols for certain electrical appliances, and you need to learn all these symbols. Much of them, like most of them, are very easy. For example, for voltmeter, you know that that's just a V. For ammeter, that's just an A in the circle. Now use the symbols in table 10.1 to draw circuit diagrams of the electric circuits in 10.2 and 10.3. So now we are going to make a circuit diagram. For this, I'm going to use this simulation. So we have 2 batteries. I'm going to clear this. We're going to have 2 batteries. I'm going to connect these 2 batteries. We're going to have 2 batteries, 1 bulb and 1 switch. Over here, this is an open circuit and this is a closed one. So, and we have to make a circuit diagram. So remember, we are going to use symbols. So I'm going to tell you how I'm going to convert it into symbols. I'm going to have a switch, and then I'm going to have a bulb. So well, let's just make it like this. Now, when I have opened the switch, then it means the circuit, the current will not flow, right? So this will not light up. But when I'm going to close the switch, you see that a bulb is lighting up, right? So if I want to convert it into the circuit diagram, I'm going to use symbols. So this is for the cell, right? In this case, as your book says that for batteries, you are basically going to use this symbol, right? So you're going to have 1 positive, 1 negative, 1 positive, 1 negative. Then for the bulb, you're going to make a circle and a cross sign in between. For wires, you're just going to make a line. And then for a switch, for a closed switch, you're going to make this switch. For an open switch, this line is going to move above. Now for series and parallel circuit. So series circuit basically means that there's one path, and parallel circuit means that there is more than one path, right? So we are going to see that. And then we're going to decide which one is a series and which one is a parallel. So from positive terminal, the current starts moving. Now, do you observe that there's one path that you have in between the positive and the negative terminal? But when you adopt this path of this path, then you see that this path further splits into 2 paths, right? So the one way through which you can reach the negative terminal is this, and the other way through which you can reach the negative terminal is through this path. So you see that there are 2 paths. So which one do you think is a parallel and which one do you think is a series? So this is going to be a parallel and this is going to be a series circuit. Electrical components are connected to one another in a single loop. Well, there is single loop and there is no single loop, right? This loop further splits into other loops. B, 2 or more paths. So this is for the parallel. One path only. So this is for series. Current stays same. So remember class, in this, in basically the parallel circuit, the current is going to divide, and in the series circuit, the current is going to remain same. Now, breaks in any part of the circuit stops the flow. Break in one of the branch still let the current flow through other branches. So when there's break in any of the branch, for example, if this branch is not working, the current will still flow through this path and reach the negative terminal. So this bulb will light up, but of course this bulb is not going to light up. But if there's a gap over here, then you know that both of these bulbs are not going to light up. Now, fault finding using knowledge of circuit ideas. How are you going to find out a fault? For example, if your circuit is not working, then that might be because the connections are not properly made. So you can check the connections and replace each component with a working component to see if the component is faulty. So you're going to replace each of the component with some working component that you already know. For example, if you're sure that this is a working component, you're going to replace that other component with the working component. But this is of course going to consume a lot of money, and then because you are replacing each of the component, the best method is this, where you test each component to see if it is working or not. So first you just use the wires in another circuit and see if that properly working circuit is still working or not. So if it is working, then that means that the wires, there's no fault with the wires, right? Now you take the bulb from the faulty circuit and you use that in the working circuit. And if that bulb isn't working, then that means that probably the bulb is faulty.